We know what happens when we take the inverse sine of sine, or the sine of inverse sine, when our do and our undo functions are the same function. However, we have not yet seen what happens when we have two functions that are not the same, such as cosine of inverse sine of something. We've done these problems before. Okay, remember back to when we said if sine of theta equals negative 9 over 41, what is cosine of theta? This is essentially what we're asking here. We've got some angle and we know the sine of that angle. So what does that make the cosine of that angle? So the way I like to do these is to start off by drawing a triangle, just like we did back in Unit 1. So we'll come up with a triangle. This is negative 9 over 41. So what that tells me is that for sine of theta, there's some angle out there, sine of theta, where its opposite is negative 9 and its hypotenuse is 41. Now I know when we drew triangles at first, we didn't talk about opposites of a triangle being a negative number. But if we have it on the in standard position, what that means is that our y value is negative 9 and our distance is 41. And so this is what we've got right now. A triangle where the y value is negative 9, the hypotenuse is 41. And if we do our Pythagorean theorem, we'll find out that let's see, a squared plus b squared equals c squared, or in this case, x squared plus y squared equals our hypotenuse squared. So I'll put in a negative 9. We get x squared plus negative 9, the quantity squared, equals 41 squared. And once we punch this into our calculator, we'll find that this is 40. So we now have come up with a triangle that has a sine of theta of negative 9 over 41. So the question becomes, what is cosine of theta? So we just look at cosine of this theta is adjacent over hypotenuse, and that gives us that cosine of inverse sine of negative 9 over 41 is going to be 40 over 41. So let's look at sine of inverse cosine of negative 11 over 61. Again, we're saying that this inverse cosine describes an angle where its adjacent is negative 11 and the hypotenuse is 61. Or in terms of angles in standard position, our x value is negative 11 and our distance, or our hypotenuse, is 61. So we can build that triangle. We have a negative 11 as our x value, 61 as our hypotenuse, and this is the theta we're describing. So now to find sine of this angle, we need to figure out what the third side is. And again, Pythagorean theorem. Be careful when you're doing these, because a lot of the time people mess up with the Pythagorean theorem because they'll say, well, a squared plus b squared equals c squared, and they'll just grab the two numbers and say that those are a and b. We've got to make sure we recognize that 61 here is the hypotenuse. So if we're looking at negative 11, the quantity squared, plus b squared equals 61 squared. So we're going to square the 61, subtract off the negative 11 squared, and then see what we get. It turns out that what we're going to get is a 60. So that means that sine of inverse cosine of negative 11 over 61 means that sine of whatever angle gives us that, and we've come up with a triangle that describes that angle, And that gives us the sine of this mess, sine of inverse cosine of negative 11 over 61 is going to be 60 over 61. What if we had sine of arctan of negative 21 over 20? Again, I'm going to start by drawing a triangle. Arctangent describes an angle that's over on this side. And we know that tangent is positive up here in the first quadrant and it's negative down in the fourth quadrant. So when we build our triangle with a negative 21 over 20, we're going to need it to be down here in the fourth quadrant. Now the question is, which is negative? The x value or the y value? Well, we know in the fourth quadrant we have a positive x value and a negative y value. So we're going to make the negative go with the 21 because tangent again is y over x when we're using the unit circle to define it. So our 20 is going to be our x value and our negative 21 is going to be our y value. And then we need to figure out what the hypotenuse is. And in this case we will take 20 squared plus 21 squared, which is going to be 400 plus 441, which is 841. And I think we'll find that that square root of 841 is 29. I've been picking nice numbers. So in this case, if we want to know what sine of this theta is, we're just going to need to take the opposite over the hypotenuse, and sine of arctan of negative 21 over 20 is going to be negative 21 over 29. Okay, that's the cases where we're doing a do-undo. What about when we're doing the undo and then the do? It's not as much trouble as it is when we have the same functions on the inside and the outside. When we have different functions, we just need to process it. Cosine of 3 pi over 2 is 0. So all we're asking is what is inverse tangent of 0? And that would be 0 degrees, or since we were given radians to begin with, let's leave it radians, 0 radians. You don't have to write the radians usually, but since it's 0, it's not really clear what we're talking about, so I like to leave the radians. What about tangent of, inverse tangent of sine of that same d? Alright, this is the case where sine of 3 pi over 2 would be negative 1. So this is just asking what is inverse tangent of negative 1. And we remember that the place on this side of the unit circle where tangent has a value of negative 1 would be at negative pi over 4. So that's our answer.